Alright, so we are going to evaluate the integral of 1 over x squared plus 3x plus 2. And we are going to do this by using partial fractions because the denominator of this integral is extremely hard to anti-differentiate. But if we can split it using partial fractions, we'll develop an expression that is easier to work with. So the first thing that we're going to do is factor the denominator of this expression, giving us the integral of 1 over x plus 2 times x plus 1. And next we are going to separate the two vectors into two separate fractions. So we're going to do a over x plus 2 plus b over x plus 1, and then set that equal to the original 1 over x plus 2 times x plus 1. And then we're going to multiply through by the common denominator, which is x plus 2 over x plus 1, to get rid of all the denominators and get an expression that's easy to work with. So on this side, your x plus 2 and x plus 2 cancel out, giving you a times x plus 1. For b, your x plus 1s would cancel out, giving you b times x plus 2. And for the answer, the whole thing cancels and you just get 1. So the next thing we're going to do is find the zeros of this denominator and plug them into this equation so we can find out what a and b equal. So by setting this equal to 0, we can find the zeros. So they are -1 and -2. And then we are going to plug those zeros into this simplified version of our partial fraction. And we should get that b is equal to 1. And a is equal to -1. And then using these values that we found for a and b, we're going to plug those back into this original expression and take the integral of that. So the simplified expression that we found for this is -1 over x plus 2 plus 1 over x plus 1. And again, we're just taking these values we found for a and b and plugging them back in here. And we're taking the integral of that. And one of the rules is when you have 1 over x and you're taking the integral of that, you take the natural log of the denominator. Since this is a variation of 1 over x, we're going to do the same thing here. So the integral of this equals -1 ln of x plus 2 plus ln of x plus 1. So again, we just took the natural log of the denominator, multiplied it by the numerator, and got this expression, which is an evaluation of this integral using partial fractions.